All right, this is the first part of assignment 8, and it deals with radicals. This symbol is called a radical. I know you're used to calling it square root, and the symbol itself is called a radical because you can sometimes put another number besides just nothing right here. Like you could put a 3, and then that would be the third root. So what number times itself 3 times gives you that number. We're just going to be dealing with square roots, but you do need to know that that symbol is called a radical. And remember, when you're doing this, when you're taking the square root of something, like if you're taking the square root of 25, you're trying to figure out what number times itself gives you 25. So that would be 5 times 5, and then when you take the square root, it just comes out to regular 5 without the radical symbol anymore. This is the first part of assignment 8. It's going to deal with the radicals. Then we're going to deal with Pythagorean's theorem, and I'm going to show you on here how on your calculator to do the Pythagorean theorem problems, because when we get to them, I don't want you to do what I'm getting ready to show you dealing with radicals. On them, I just want you to give the decimal answer. There's a radical answer, which is an exact answer, and then the decimal answer, which normally is rounded off. So with your calculators, what you're getting normally is the decimal answer. So if you have this calculator to do the square roots or do the radicals, do the square roots, because radicals is a different setup. If you just do the third root or fourth root, you hit the second button here, and then you hit the x squared button. If you notice right above the x squared button, there's a radical, a square root symbol. So you hit that, then you hit this, and then you put in your number, and it will give you what number times itself gives you whatever you had under that radical. On the other calculators, on the bigger ones, same thing. Second button's right there. And then same idea, the x squared button's right here, and right above it is the square root symbol or the radical symbol. So that button next, and then you put in your number. Some of you, if you have an older calculator, you might have to put in the number first, then hit the square root button. And some of you, if you have a Casio, it might be a good thing now, because what we're going to do first is we're going to learn to simplify these radicals. And when you simplify the radicals, that means you leave it in radical form. You don't just get rid of the radical like most of these calculators do. So the Casios have it in radical form, or will give it to you in radical form. And some of you, if you don't want it in radical form, if you just want decimal form on your Casio, you're going to have to go to the mode button, and on that mode button you'll have to change it. And I don't have a Casio here handy, but you're going to have to change it and figure out so it gives you just the decimal form. I think it's called, it might just be like Math 1 or number, something like that. I can't remember on the Casios. But on the Casios also, what we're going to talk about next, it will take a radical and it will simplify it in radical form. And radical form is a lot of times better because it's an exact answer. When you use your calculators to do this other stuff, you're rounding it off and you're not getting an exact answer anymore. So when we leave it in radical form, you're being more precise. All right, the first thing we're going to do, dealing with these radicals, just simplifying them, and there's several different ways to simplify them, and I'm going to show you a few of them. Then we'll do some problems off the worksheet also. The first one's here, you're simplifying this. First thing you got to remember is your perfect square numbers. These are the perfect square numbers all the way up to 400, And all that's saying is if you take the square root of any of these numbers, so if you take the square root of 225, it's going to come out even. It's going to come out as a whole number, not rounded off, not anything. It'll just come out as a whole number, and that one happens to be 15. So here, this is, all you're doing is this is 2 squared, that's 3 squared, that's 4 squared, that's 5 squared, that's 6 squared, that's 7 squared, 8 squared, 9 squared, so on, all the way up to this last one here is 20 squared. So if you took the square root of 400, you end up with just 20. Those are perfect square numbers, and we're going to use those to simplify these radicals. Almost like your trees that you made back in 4th or 5th grade, when you had a number like 75 and you broke it down, and you probably broke it down into something like 25 times 3. It's the same idea here. You're going to break these radicals down, but what you want to find is you want to find a perfect square number that will divide evenly into each radical. So, and that's what I'm going to do on this one. Now, with your trees, you keep going and you break it down farther. With these, you don't. On this, all you do is you break it down. So we're going to break it down in square root of 25 because that's a perfect square number, times the square root of 3. When you do that, then the square root of 25, you can take the square root of 25 and you get 5. The 3 you can't do anything with, so it just stays under the radical. And your simplified form is just 5 times the square root of 3. That's the exact answer. That's the way we want to leave it. It's just simplifying it down. It's like simplifying a fraction, only dealing with radicals, dealing with those square roots. And again, this is red. 5 times the square root of 3. If we do the next one, perfect square number that'll go into 18 is 9. So I'm going to break this down into the square root of 9 times the square root of 2. Well, the square root of 9 is 3, so that just comes out of the radical. And the 2 stays under the radical, and you're left with 3 times the square root of 2. That's your simplified answer. Next one, I put this on here because a common mistake that a lot of students make is they see this and they go ahead and they try to divide because that's what they're used to doing. But since this is a radical, since this is a number under the radical, and this is a 2, it's almost like they're x's and y's. They're 2 different kinds of numbers. You can't just divide them. So what you got to do here is you got to try to break down just this top, which that top, I'm going to leave the 2 on bottom. That top will break down into 4 is a perfect square number. They'll go into 12. So square root of 4 times the square root of 3. Well, the square root of 4 is 2. So you end up with 2 times the square root of 3, still over 2. Now, this 2 and this 2 are regular numbers, so those you can reduce. And what happens with them is they just sort of cancel each other out, and we're left with just the square root of 3. So this whole thing simplifies down just to the square root of 3. And if you took your calculator and you did the math and worked this out and took the square root of 12 divided by 2 and wrote down that answer and then took the square root of 3, you would get the exact same number. The second way to simplify is by rationalizing. Rationalizing, when we have a radical in the denominator, and a lot of books are different now. A lot of books just leave them this way. But rationalizing, when I was taught radicals, you could never ever leave a radical in the denominator. So what you do here to get that radical out of the denominator is you multiply the top by whatever that square root is on the bottom, and you multiply the bottom by the same thing. When we're multiplying by that, we're just multiplying by 1, so we're not really changing anything. And when you have these and they're both numbers under the square root symbol, then you can multiply them together, just like you would multiply any other number. So on top, we end up with square root of 24 On bottom, you end up with the square root of 4. Well, on bottom, that square root of 4 is just going to end up being 2, because that's what the square root of 4 is. On top, we could simplify that just like we did on the last part, and we find a perfect square number that will divide evenly into 24, and 4 will. So I'm going to break this up into the square root of 4 times the square root of 6. Well, the square root of 4 on top, and I'm going to go down here to write it. Square root of 4 on top, that is just 2, so that comes out of the radical. And you still got the square root of 6 on top and 2 on bottom. Then you can simplify that a little farther by canceling out these 2's. Since they're both regular numbers, you can just cancel them out, and we're left with just the square root of 6. So this and this are the exact same numbers, just this one's in simplified form. So rationalizing, you notice here, rationalizing, we got rid of that radical in the denominator. It was no longer in the denominator, and that's what rationalizing is. Some of you might have looked at this one and said, well, I could have just divided those two and got the square root of 6. And you're right. As long as they're both radicals, you could just simplify it just by dividing these two, but they have to both be radicals. They can't be one of them a regular number and one of them under the square root symbol. So on this one, we could just divide this and say 18 divided by 2 and get the square, and it's still going to be under the square root. Square root of 9. Well, the square root of 9 is just 3. Comes out of the radical, and 9's a perfect square number, so it's just 3. This one, we could try that same thing, but 3 won't divide evenly into 14, so that doesn't really help. So what we're going to do here is multiply the top by the square root of 3, multiply the bottom by the square root of 3. On top, I get the square root of 42. On bottom, I get the square root of 9. The whole purpose of rationalizing is to get rid of this radical in the denominator, and you'll notice now that we have square root of 9, which is a perfect square number. So that bottom now is just 3. On top, we still got the square root of 42. You can't divide 3 into 42 and simplify it that way, because one's a regular number, one's a radical. You can go through here and you can try to figure out to break down 42 if any of these perfect squares will divide evenly into 42. 4 won't go into 42 evenly. 9 won't go into 42 evenly. 16 won't. 25 won't go in there evenly. 36 won't. 49's too big, and anything else is going to be too big. I just realized that should be 256 here. It printed off with the 56 down there. So this is in the simplest form. It won't go any simpler than that. Next one's if we're multiplying with radicals. If we're multiplying with radicals, since they're both under the square root symbol, you can just multiply the numbers together like you would any other number. So here I got 5 times 20, and it's going to stay under the square root. 5 times 20 is 100. Square root of 100. 100's a perfect square number, and that's just 10. So 10 times 10 gives us 100, so we just take out one of the 10s, and that's our answer. Next one, we multiply these and we get square root of 18. We just got done doing this on one of the other ones. And again, it's like you're doing your factoring trees. We break this down into one of these perfect square numbers, which this time is 9 times the square root of 2. Well, the square root of 9 is 3. And the 2 stays under the radical, under the square root symbol. So you get 3 times the square root of 2. That's your simplified form. Again, all of this is just like simplifying a fraction. So if you got 4/8 and you want to simplify it down to 1/2, then that's sort of what we're doing here. And these are all exact answers, so that you're not using your calculator and rounding everything off all the time. Next one, when we have something like this, we can take the regular numbers and multiply them, and then we take the numbers under the square root and multiply them. So here, 3 times 4 is 12. That stays outside the radical, outside the square root. Then under the square root, 5 times 15, that's 75. Now we try to simplify down this 75, and we look up here, and a perfect square number that'll divide evenly into 75 is 25. So I'm going to break this apart and break it into the square root of 25 times the square root of 3. And I know I'm working this out step by step, and a lot of them you won't have to work it out step by step. You'll be able to skip a few of these steps. Well, the square root of 25 is 5. So the 12 stays the same, times the 5 comes out of the radical, and then the 3 stays under the square root, or under the radical. Well, these numbers out front now, we can just multiply them together. 12 times 5 is 60. And then you still got the square root of 3, so the simplified answer is 60 times the square root of 3. The last part with radicals is adding them together. Adding or subtracting. I only put addition on here. I'm not sure why. Just being lazy, I guess. But this works with adding or subtracting. When you're adding or subtracting or multiplying or any of this other stuff, you got to treat these like variables. So if I had something like 2x plus 5x, that would give me 7x. You just add or subtract the coefficients and keep the x the same. It's going to be the same with the radicals when I show that to you here in a minute. The other thing is, if you had something like 2x plus 5y, these aren't like terms, so that's your simplified form. And that's the same thing with a radical. Treating these radicals like they're the x's or the y's. First thing, I look here and I got a 5 and I got a 20. Well, they're not alike. They're not the same under the radical there, so I can't just put them together. I can't just combine like terms there. But what I can do is I can leave that 5 radical 5 like it is, and I can try to break down this square root of 20, because 4 will go into, is a perfect square number that'll divide into 20. So 4 square root of 4 times square root of 5. Well, the square root of 4 is 2. So I get 5 times the square root of 5 plus that 2 comes out of the radical. And you got times the square root of 5. Now you'll notice that the numbers under the square root are the same. So it's like having a 2x and a 5x. Just treat this like this is an x, like that's an x. So 5x plus 2x gives you 7x, or in this case it's 7 times the square root of 5. You don't add those two together, you just keep it square root of 5. So it's 7 radical 5. So it's just like saying, you know, this was 5x plus 2x, and you end up with 7x, only your x right here isn't an x, it's a radical or a square root of 5. Next one, if you had something like this and it said 7x plus just x, you got to remember that the coefficient in front of that x is a 1. So you just add those two together. Well, it's going to be the same thing here. So we just add the 7 and the 1 and we get 8. And then the number under the radical stays the same. So it's 8 times the square root of 3. Next one, we look at these, and these two are like terms. So we could just go ahead and add those together or subtract them if that was the case, but here it's addition. So it's 3 plus 6, well that's 9 times the square root of 5. The square root of 15, we could try to break it down but there is 4 won't go into 15 evenly, 9 won't go into 15 evenly, and 16 and everything else is too big. So that won't simplify any farther. So we write down 4 times the square root of 15. That's as simplified as that expression can get. It will not get any simpler. That's the exact answer. If we wanted a rounded off answer, then we could take our calculator and plug all that in and get that answer. When we're doing Pythagorean's theorem, you're going to take your calculator and just give me the rounded off answer. But you also have to know how to deal with these radicals for when you go on to other higher level maths. All right, this is the worksheet. You could stop the video here if you wanted. I'm going to go ahead and work it out. You could stop it out and try the worksheet yourself, then come back to it maybe and check your answers. I'm going to go through and try to do most of these. We'll see how many I actually get done in the amount of time that I want to spend on this. But I'm going to go through them pretty quickly. And again, the second part is going to be over Pythagorean theorem, so that'll be a completely separate part of this assignment. The first one here, I look at this and I see that this will break down into the square root of 9 times the square root of 10. 9's a perfect square number, so that comes out of the radical. That's 3 times the square root of 10. That's your answer. 3 times radical 10. Next one, 148. I know 4 will go into it. Might be a bigger number that'll go into it. And you usually want to try to find the bigger number, just like with simplifying fractions. So I grabbed my calculator and I tried to divide 16 into it. I tried to divide 36 into it because they're both perfect square numbers. Neither one would go in evenly. So I'm just going to go with 4 and see what that gives me. So break it up into the square root of 4 times 148 divided by 4 is 37. The square root of 4 is 2, so that comes out of the radical. 37 stays under the radical. That's in simplest form. 2 times the square root of 37. 169. 169 is a perfect square number. If you take your calculator and you take the square root of 169, you should end up with 13. So that whole thing comes out of the radical and you're just left with 13. 20. Break that down. I think we did this on the examples. 4 will go into that, so we break it down in 4. Square root of 4 times square root of 5. Square root of 4 is 2. That comes out of the radical. Square root of 5 stays under it. That's your simplified form. 175, I always think of money anytime you're dealing with like 150, 175, 250, any of those numbers. Think of quarters, because 25 is a perfect square number. So I break this down into square root of 25, and then there's in $1.75 there's 7 quarters. So 25 times 7, square root of 25 is 5. That comes out. The 7 stays in, and you're left with that number. Next one, 80. 4 will go into 80. But I think maybe 16 will go into it. So if I grab my calculator and I say 80 divided by 16, again, we want the biggest one, biggest perfect square number, and 16 will go into it. It's 16 times 5. It's just like reducing down a fraction. If you don't reduce it down enough the first time, then you got to do it again. So you'd like to get it all done in one step. Square root of 16 is 4. 5 stays under the radical, so 4 times the square root of 5. Next ones, notice that these are both the same under the radical, so we can just put them together. We could add or subtract them. Whichever we're doing here, we're adding, but all you do is you add or subtract the coefficients. So 3 plus 4 is 7, and then the number under the radical stays the same. So that simplifies down into 7 times the square root of 5. Same thing on the next one. You're just adding the 3 and the 5. You get 8 times the square root of, oops, not 5, square root of 2. Next one, we're multiplying here. So we can just multiply, even though these aren't the same, you can just multiply them together and you get the square root of 24. Then we try to simplify that. Square root of 24, 4 will divide evenly into that. So we break it down into square root of 4 times the square root of 6. Well, the square root of 4 is 2. And you still got times the square root of 6. So that's just 2 radical 6 is your simplified answer. Next one, we're going to rationalize this one. So we're going to multiply the top by square root of 2, bottom by square root of 2. That gives me square root of 16 on top, square root of 4 on bottom. Well, the square root of 16 on top is just 4. The square root of 4 on bottom is 2. And then we can just divide this because they're both just regular numbers. 4 divided by 2 is just 2. So that whole thing, no radicals left in it, it's just 2. Next one, we multiply the coefficients, the numbers out front. We can multiply them, and we multiply the numbers underneath. 5 times 4 is 20, times 2 times 8 is 16. Then we try to simplify this radical down. Well, 16 is a perfect square number, and it's just 4, so we end up with 20 times 4. And if we just do the math there, 20 times 4 is 80. So all of this simplified down into exactly 80. If you would have did part of it on your calculator, then times it by the other part on your calculator, it would have given you a rounded off answer, and it wouldn't have given you this exact answer. Next one, we multiply the numbers out front. That's 12. Numbers inside, 6 times 2 is 12. We can simplify this radical 12. 4 is a perfect square number. They'll divide evenly into 12. So 4, square root of 4 times square root of 3. Square root of 4 is 2. So that's going to come out of the radical. And we still got times the square root of 3. 12 times 2 is 24. So we end up with 24 times the square root of 3. Next one. On this one, there's several different ways you could do this. First thing I would probably do is the 10 and the 5. Since you're just multiplying here, you can simplify that, and it's going to end up 5 will go into 5 once, 5 will go into 10 twice, and you end up with just 2 times the square root of 2 on top. Oops, square root of 2. And the square root of 3 all by itself on the bottom. Now we don't want that square root of 3 on the bottom, so we're going to multiply the top by the square root of 3, and we're going to multiply the bottom by the square root of 3. On top, the 2 is going to stay the same. We take this square root of 2 times that square root of 3, and we get square root of 6. And on bottom, you got square root of 3 times square root of 3, which is square root of 9. Well, the square root of 9, the whole purpose of rationalizing is to get rid of that radical in the denominator. Square root of 9 is just 3. And on top, we still got 2 times the square root of 6. Be careful here. The 2 and the 3 are the regular numbers, and they won't reduce down any. All right? And you can't reduce the 3 and the 6 because one's a regular number and one's a radical. So that's your simplified answer. The last one here, we look at all these and we notice that this one has a radical 3 and this one has a radical 3, so they are like terms, so we can put them together, and all we do is take the coefficients and either add or subtract them. This time we're adding, so 3 plus 6 is 9, and the radical 3, the square root of 3, stays the same, plus 5 times the square root of 2. We can't do anything to these. You can't put them together because they're not like terms. So that's your simplified answer. Again, this is for radicals. The other part of this video is going to be dealing with Pythagorean theorem And on Pythagorean's theorem, I'd actually want you to use your calculator. And if we had something like this one, 7 times the square root of 5, which we won't have, but I'd rather you just hit second, square root, put in the number 5, hit equals, and give the decimal answer. Some of your calculators will give, if you can figure out how to do it, some of the newer calculators especially will take radicals and they'll simplify them down for you just like they simplify down the fractions for you.